So I just want to show this little visualization first. Oh wait, wrong link. Nested loop. And there's a few different visualizations in here, but the main one I want to show is just this first one, and then we'll go over to writing some code. Um, so this is the code that we're going to be kind of like reviewing and going over today. And this is what it kind of looks like if we kind of spread it out instead of doing it all at once. And so I think hopefully this will kind of like make it easier to understand what's happening. But we'll look at this and then we'll write it out in P5 and then we'll come back to this. So as usual, let me know if you guys have questions, if you want me to go over anything again. But in this code, you probably recognize this first bit, this for loop at the top here. This hopefully looks familiar. It probably looks similar to, oh, I made this not editable. So actually, let me open up my screen brush. I can just write on here. So hopefully this top part here looks familiar. We start a loop with let x equals 0. So this is our starting position. And then we have the condition where we want to stop. So as usual, we're starting at 0 just because our canvas starts at 0 over here. So this is x is 0. And then width is the other side of the canvas over here. And so since we're drawing a pattern, we want to fill up the whole canvas, we're going to start at 0 and we're going to keep counting until we get to the width. So as long as x is less than or equal to the width over here, we're going to keep counting. And so then our counting condition is at the end, x plus equals 100. And so we're going to move by 100 each time. So x starts at 0 and we do what's in here, and then we move by 100. So we count up by 100, and then we go to here again. We count up by 100 again, go to here again, count up by 100 again, and eventually we're going to hit here. I should have drawn these arrows a little bigger. But anyway, we count up by 100 again, and we're going to hit this width. And then once we go past, like over here, it's going to say, well, that's not less than or equal to width, so we're just going to stop here. So the difference with this loop is that there's actually a new loop inside of the loop. So each time we go through this first X loop, we're going to go through this entire Y loop once. And it resets when we get back to the beginning. So that's kind of the tricky part. So we have this new loop inside of our X loop, and it's doing basically the same thing except for Y. So Y is going to start at 0 up here. So 0, 0. And we're going to count until we get to the height at the bottom of the canvas down here. And then we're going to go up by 100. So when x is 0 here, before we even start our x loop, we're actually going to do a loop here. We're going to go down by 100, and we're going to keep going down by 100 and looping through our y loop until we hit the height. When we go past the height down here, we're going to stop. And then we go, remember, we loop all the way back up to here, and we increment x by 100, and then we do the whole thing again. So that's kind of the power of doing a nested for loop, is we have one loop that gets repeated over and over again inside of our other loop. And then all that's happening right here is very simple. We're just drawing a circle in the middle of each one of these little squares. So we're gonna have a circle here, 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 and then eventually we're gonna fill up our whole canvas. So I wrote this one so that we could watch it happen. So when I click loop, our first loop, x equals 0, y equals 0. So let x equal 0 and let y equal 0. That's where we start. And then when I go again, now we're in the y loop. So y is up by 100, but x is still 0. So we just loop in here. And then we go again, y plus 100, y is 200. We go again, y plus 100, y is 300. And now if we loop again, this loop ends because y is greater than the height. So we go back to the beginning. Now x plus equals 100, but notice y is back to 0. When we come back to this loop, we're starting it again from scratch. And so we loop through all of our y's again. We move over on x, loop through our y's again, move over on x, and loop through our y's again. So I have y inside of x. That's just kind of an arbitrary choice. You don't have to do it that way. You could have the X loop inside of the Y loop, or you could have other ways of setting this up. But that's basically what we want to do in order to create a grid for each column. So we can think of X as our columns. So we have one column here, one here, one here, and one here. For each one of those columns, we're looping through all of our rows. And so that way we get a nice big even grid. And then we can do the same thing with our pattern variations, but in this case, we're going to do it on the X and the Y axis instead of just the X axis. So let's go over and code this up, and then uh, we can think about how to turn it into a pattern. So I'm going to go over to the P5 editor and log in. Oops. And I'm just going to save this as a new example. So this is nested loop. Fall 2022. And for now, we're just going to focus on the nested loop. We're going to add some variations on Wednesday, but for now, since this is a new concept and it can be a little tricky, we're just going to focus on creating the nested loop and then adding some shapes inside of it. So nested for loop example, November 14th. Okay, so most of this stuff is going to stay the same. In here, actually, let's get rid of our draw function for now. So just like we did with our first pattern example, we don't really want a draw function here because that will redraw the loop over and over again. And eventually we're going to add some randomness in here. And it's not going to be interactive, so we don't really need the draw function. So let's just go straight from create canvas to drawing a background, and then we can draw our nested for loop. So we start with our basic for loop. So for let x equals 0, x is less than width. And you could do less than or equal to. If you have even numbers, having less than or equal to will help out a little bit here. If there's not even numbers, then it doesn't really matter that much. And then we can say x plus equals. Let's just use the example. I'm going to put some variables in here a little bit later. But for now, let's just do x plus equals 100. And I'm just going to draw an ellipse for now at x. And let's hard code y for a minute. Let's call y 100, and the size is 100. Okay, so there's our basic for loop. If we want to move our circles into the middle, like in the example we saw before, I can just add half the size here to x. And so because the circles draw from the middle, we need to increment x over here to get the circle to kind of fill up the shape of the column. So that's not necessary, but you might want to do something like that. And then just like we did with our patterns, we could begin to design within this for loop. We can add other shapes, we can change the color, we could do different things to change the pattern, create variations, etc. But for now, let's look at what happens when we add in our nested for loop. So all I have to do here is stay inside of my for loop. So the first X for loop, starts and ends with these brackets. And I want to add a new for loop in here. So I just write for just directly inside here. And it's going to look almost exactly the same. For let y equals 0, y is less than or equal to height, and y plus equals 100. So it looks almost exactly the same except for on the y-axis instead of the x-axis. And so if I move my ellipse in here, now the ellipse is inside the y for loop. And so this is our nested for loop. Nested just means that something is inside of something else. So when you're writing HTML and you have like a paragraph inside of a div, that paragraph is nested inside the div. And you can think about a nest like a bird's nest, like the eggs are inside the bird's nest. So when we nest something, that just means it's inside. And we do that a lot in code. Everything in here is nested inside setup. And everything in the X for loop is nested inside that loop, and same thing with the Y loop. The reason we call it nested here is because we have two loops nested one in the other. And so anyway, we run this code and we don't see anything yet because I didn't update y. Let's stick y in there. And there we go, we have our grid. And let's add 50 to y, just like we did in the other example. And now we have this nice perfect grid. And so let's look at what we can change here and what all of these different parameters do. And then we can also add in some variables so we have a little bit more control over how the grid looks. But this is the basic idea here. Instead of just creating a row, we're creating a whole grid, and we're doing it with very little code. So this is really just, 5 lines of code, and there's only one sort of like image being drawn here. So let's change the variables around a little bit, and then we'll change the design a little bit, and then we'll add some variables, and that'll be good for today. So the first parameter is where we start. This is pretty easy. This just changes where we start in the canvas. So if I change this value, if I change x to 200, I only get a grid on one side of the canvas. So we start counting here at 200, and that's our first ellipses at 200 plus 50. And so the end is still the same, right? Because we didn't change width, we just changed where we begin. So the number of columns we get is a kind of a combination of where we start and where we end, and then how big the columns are. So I can change the ending as well. If I change this to 300 or maybe 299, we're only going to get one column. Um, so that, that'll happen if once we count 100, we're past 299. So we only got to draw one column there. And if we go beyond the width, it doesn't really matter because we can't see past the width. But if I did like 1,000 here, it would, this code will run longer. But since we don't see that far in the canvas, we don't really see anything over there. If I change the size of the canvas, obviously, then we get a bunch more columns. But for now, we're just dealing with our 400 by 400 canvas. Then the last bit is how far do we move after each column. So if I change this to like a 10, then we get a whole bunch of circles. And if I make it something bigger, like 200, then we get fewer circles. Those are the kind of the different parameters that we have, and they work the same way for each one of our loops, but in a different direction. So if I return my x back to normal, and then I do the same thing on y, if I change y to 200, we're going to move down. If I change the height, we're going to get one column. And if I change this number over here, how much we increment by, that'll change the number of times we draw this column. So if I change it to like 20, I changed this number. Let's change this back to height. We'll get a whole lot of them. So let's use some variables to make this read more like what we would want it to read. What we probably want to know as a designer is like how many columns are there and how big are the columns. And then we can use variables to sort of get that information and then use our loop to set it up according to the variables that we want. So instead of saying we want to start at X and go across by increments of 100, let's say how many columns do we want, and then we can use math to figure out the rest. So let's say cols for the number of columns, and let's say we want 4 columns, and then let's say for rows, we want 4 rows. And so let's figure out the math so that we can generate a pattern, or generate a grid rather, that fits with the number of columns and rows. So we have to think about how big our space is, and then how to divide it up. So we know the width and the height. Those are variables that are given to us by P5 after we set up the canvas. And so we need to know the width and height of our shapes in order to set up our grid. So let's make a W as a shortcut, as a shorthand for width. And what we can do is just divide the width of the canvas by the number of columns that we want. That will give us the width of one column. And then we're going to have to use this not only for the size of our shape, assuming we want this shape to match, but also for how much we increment by here. So then we can do the same thing with height. So we say let h equal height divided by rows. So now we can deal with the number of columns and rows rather than uh, the uh, the width of each shape. And you could do it the other way around too, right? If I wanted to have a grid that had a specific column width and row height, and I didn't care what the number of columns or rows was, I could start with this number and then reverse engineer this number based on the same math, just in the opposite direction. So let's put these variables in. Basically, I take the width here and substitute it for that 100, and I take the height here and substitute it for this y value. And now for my ellipse, the x and y are going to stay the same, but for the size, I'll use width here. Since it's a circle, I don't need to use width and height. But if we change it, we might want to. So let's take a look at that. So now I can change the number of columns. So if I change the number of columns to 6, now see that we get 6 columns. Our offset is a little bit off, so we'll fix that in a second. But we get our 6 columns, 1, 2, 3, 4, 5, 6, and we still have 4 rows, 1, 2, 3, 4. So our offset is a little off. So that's why they're not matching up. But the other reason is because we don't have the same number of columns and rows, and we're using a circle. So we'll have to fix that as well. If I change this to 6, then it starts to line up a little bit better, but our offset is still off. So this 50 is based on the original width that we had, 100. It was hard-coded. So for the size, what we want is half of the width. So let's just say let size, or no, this is really the offset. Let's just do the math here. So let's just say width divided by 2. So now our offset is fixed. We can do the same thing for the y. We can use height divided by 2 in this case. So that fixes our offset. So the 50 was based on the previous 100, but when I change the number of columns, now this offset value changes. So we have to use half of the width instead of the hard-coded 50. So if I make like 12 columns now, it'll line up. And if I make like 20 rows, it'll line up. We are starting to overlap a little bit. So if I wanted to use the height instead of a general size, now I have these squished circles, the ellipses with a different width and height. But now we can start to see I have this grid that I can start to play with. And my ellipse has to be offset because we draw the ellipse from the middle. But if I draw a rectangle, I can just say rectangle, x, y, width, and height. And that's just going to fit exactly in there because we are, with our grid, we're starting at 0, 0, and then we're going over by width and down by height. So the rectangle, which draws from the top left by default, is a little bit better suited just for visualizing our grid. So let's reduce the number of columns and rows a bit. So that looks a little bit better. And then I can also, if I change the canvas, since I'm using these variables, the columns and rows will update with the canvas. Let's say if I make it taller, that'll update as well. I could also set the number of columns, based on the number of rows if I wanted to. Let's see if we make this even. I'll do 6 by 8. So then we get a square. So depending on what you want, you can either set the number of rows and columns, or you can decide how big you want your cells in your grid to be. But when we're designing, usually we want to think about big, kind of the big picture, the basic design behind, or the basic structure behind our design. And so columns and rows make sense here. We can think about, if I have a design, I want a certain number of columns and rows, and then I can start to design my pattern based on that. So with this rectangle, we can kind of visualize where the grid is, but we don't really need to do that. We could have, different shapes, and essentially what we get is a bunch of like little mini canvases. So I'm going to get rid of my rectangle and my ellipse for a second. If I just draw an ellipse at x, y, and I'll just use a number here, then I just get, an ellipse at all these different points. And another thing that I can do with this, if I want to not have to think about the math quite as much, is I can translate to that position, and then I can just use, hard-coded numbers there without having to worry about what their relative offset is to, offsetting everything here. So if I, instead of doing an ellipse at xy, if I translate to xy first, now I can do an ellipse at 0, 0. Oops. I guess I must need to push and pop. I thought it would reset, but let's try it. So if I push and then translate and then pop, um, so hopefully you guys remember our transformations from a few weeks ago. Now I can just draw an ellipse at 0, 0, and it's like I have a little mini canvas to start my design all over again. So I can still use like width and height. Like if I want to draw, let's say I want to draw, um, let's say I want to draw an arc that fills up my uh, my section. I could draw an arc from 0, 0, and I could use width as the width and height as the height. And for the arc distance, let's start with 0 and pi and see what that looks like. Okay, so now we have like a nice little arc that covers each one of our sections. Although with the arc, we are offset by a little bit. So I could do like width over 2, and then it would actually match the area because the arc draws from the middle. So we could move over to width over 2 and then draw from that section. I could do, 2 pi, and then I'll be drawing an arc around the whole thing. So now I'm just back to what I had before. Uh, let's go back to just pi. So now I can kind of make designs like if I were like we did with our self-portrait and our original stuff that we were making at the very beginning of the semester, except instead of having one canvas to work in, I kind of have like as many canvases as I want, these mini versions of the canvas where I can repeat these different patterns. So I have a little arc. Let's draw a little line. Let's see if we can draw a line. Um, let's see, maybe we can make like a little X. So I can draw a line from 0, 0 to width height, and that'll make like a little cross. And then I can draw another line and just start all the way across width 0 and draw that to 0 height. Okay, so I can make like a little cool cross design. So you can see how this is going to make it kind of interesting to generate different patterns. We're not even using randomness at this point, but we're already creating some more interesting patterns than what we have maybe previously. Although I guess it's subjective, but this looks kind of cool. Let's put another arc in there, and then I'll draw on it a little bit to try to explain more what's going on. So let's reverse our arc. So let's do an arc from pi to 2 pi. So that'll go in the other direction, but then let's move it down. So I'll start it at height over 2. Or maybe I need to start it at height. That's not what I thought that was going to look like. Okay, so I have the top, and then, oh, I think maybe I need this to be 0. No, not quite. Although that looks closer to what I thought I was going to get. Let's try this again. Okay, I'll just do 0 here. I think that looks kind of cool. Anyway, you can start to see I can start to create kind of an interesting pattern, although now this arc is covering up the other line, but I'm going to ignore that for now. And so let's make the columns a little bit smaller and the rows a little bit smaller and talk about what's going on a bit more. So I'm going to make like 3 columns and 4 rows and just draw on this a little bit just to explain these different lines. So let's talk about the lines first because those are a little bit simpler. So for the first line, so remember now I'm doing this nested for loop. I have all these different grid points. So this is like 0, 0. And then just in terms of like with columns and rows, I don't know what the actual numbers are because I'm just using division to figure it out, but this is x1, y0, whatever those numbers happen to be. And then down here is like x2, y0, x3, y0, x4, y0. So whatever those numbers happen to be, if it's 100, it's 1 times 100, 2 times 100, 3 times 100. If it's 200, and then over here, x is back to 0, y is now 1, whatever whatever this value happens to be. It might be 100 or 200 or 60 or whatever. And then now x1, y1, x2, y2, x3, or sorry, x2, y1. Oh, wait, no, I'm going the wrong direction. Okay, now x is 1, y is 0. Whoops. See, it's confusing. X is still 1, now y is 1. X is still 1, y is 2. X is still 1, y is 3. And down here, although we're not actually drawing these ones, so let's ignore these bits down here. This is just the bottom of these ones. Okay, so then x becomes 2, y goes back to 0, x stays 2, y goes to 1, x becomes 3, or sorry, no, yeah, 2, x stays 2, and y becomes 2, x stays 2, y becomes 3, and I think that's it. So we have this like grid now, we have these different coordinates, but we don't actually really need to know where we are because we're drawing the same thing. So this first line, it's just drawing from 0, 0. So let's delete all these. So 0, 0, this first time is right here. And then it's drawing to width, height. So width is the width of one column, height is the height of one row. So our second point is here, and we're just drawing a line in between. The next one starts over here, actually, width, and y is 0. So that's right here. And then it goes back to 0 and height down here. So this is 0 height. So that gives us a line that makes a little cross in our columns. And so then we just repeat this over and over again because we've created this design. So we don't really have to know any of this math. We just have to know the relative values, that this is 0 at the top, width on the right, and then height down here at the bottom. This would be width height if we use that. So those are our lines. So then our arcs, for the first arc here, we have to start in the middle since circles draw from the middle. So we just move over half of the width to here. And then y is just 0 since we're at the top here. So here's 0. Y is just 0. And then we're just drawing an arc that's the same width as our cell, our column. And it's actually the same height, but since it's drawing from the middle, we only see the bottom half down here. And then it's drawing from 0 over here around to pi over here. That's another good thing to keep in mind, is that those values are also relative. 0 is always here, pi is always on the other side, and then if we want to come back around, then we eventually come back around to 2 pi. So then with our second arc down here, we're starting at 0, so we're actually cutting off the arc a little bit here. And the height is h, so the height of the arc goes all the way up to here, but we're not drawing all the way down, so we're not drawing this part of the arc. We're only drawing from pi over to 2 pi. So we draw this part of the arc. So we don't see anything down here, and we don't see this for this one because it gets cut off, although we do see this one over here. And then, yeah, same thing with height, and then we draw this section. And so by combining these different shapes in these different ways, it's a lot easier to kind of throw random stuff in there and come up with some interesting results. So I'm going to stop here. I think this is a pretty good illustration. We're going to talk about some more stuff on Wednesday as far as adding randomness, so you can have a little bit of unpredictability in the pattern. But there's a lot you can do with this basic structure already. So I'm going to save this sketch and I'll share it in the voice chat for you guys to take a look at. And so for today, oh, it got kind of dark. Let's turn on the light. So for today, you can try just building the nested for loop and then creating a pattern. So the pattern doesn't have to have randomness quite yet. We'll add that on Wednesday. But if you want to just experiment with putting different shapes and different compositions together within the grid and seeing what the result is, you could probably come up with some pretty interesting patterns that way. Yeah, that's it for today. Wednesday we'll go over adding some randomness so we can add more to our patterns. Yeah, so I'll stop recording and take questions.